All right, folks, the purpose of today's lesson is to put together the last two lessons where you are using SOHCAHTOA. So we're going to use SOHCAHTOA to solve both for sides and angles together when they're all mixed up. Okay, so basically we want to pay attention to where our unknown is in the triangle, and that's going to tell us if we use the regular sine, cosine, tangent, or the inverse in order to solve. So when we start out here, that's our first decision. Is our x inside the triangle or outside? Is it an angle or a side? Because remember, last time we learned if we want to solve for an angle, we have to use the inverse. Okay, so first up, this one says we're solving for an angle because it's on the inside. I'm going to go ahead and make a note of that for this first one. It's inside the triangle, so that means use the inverse. That's just a reminder, because a lot of times when we set up these equations, even though we set them up the same way every single time, we want to make sure that we know our last step has to be using the inverse. So that's just a reminder that we have to use. Okay, so from there, it's just like we've been practicing with SOHCAHTOA. You always want to mark the acute angle in the triangle, and that is our x in this case. And from there, you can label the sides, opposite, adjacent, hypotenuse. By now, you should be pretty comfortable with that, knowing your sides. Remember, across from the 90 degrees is our hypotenuse. Across from the angle you mark is always the opposite side. And then finally, the last one left is adjacent, but it's really just next to that angle, the one that's not the hypotenuse. Okay, in this case, the hypotenuse is completely blank, so it's useful, or it's not useful for us. Okay, so anytime something is blank, you can, one, either not label it at all, or after you do, just cross it out, because we won't be using that. The leftovers tell us what we do need. We've got the letters O and the letter A. Okay, so on the top of your page here, it has SOHCAHTOA listed out. Okay, so keep that handy. And I'm going to go ahead and split it up into the three chunks here, the SO, the CA, and the TOA. So we're looking for the letters O and A in the same chunk, and that goes with tangent for us. So this is the TOA. And how we set this up is always the same. The first letter represents sine, cosine, or tangent. This one was tangent for us. After that, we always place the angle next. Then, these two letters tell us the fraction we set it equal to. In our triangle, we've got our angle here is x, and then equals our fraction. O goes on top, A on the bottom. Okay, so O is 6 and A is 10. You might want to make yourself a note of that. It's always sine of the angle equals the fraction, or cosine of the angle equals the fraction, or tangent of the angle equals the fraction, but it's always the angle that goes next. From there, we just have to solve for x, and this is what I was talking about. Sometimes we get stuck in what to do, and because this says tangent of x, that tells us kind of that we need to use the inverse, but the reason it is because right here, this doesn't say tangent times x, it's tangent of x. If you go over to your calculator and type in tangent, the first thing that pops up is a parenthesis. Okay, you have to put something in there. So to separate it, we have to use the inverse operation, which is the inverse tangent, since we were working with tangent to begin with here. Okay, I did pull up this link that I had sent you. That is an option for using SOHCAHTOA, because some of our calculators do that just a little bit strange. So this is a consistent way to show you how to do these. But we decided we're using the inverse, and remember the inverse you can do on both sides. On the left-hand side, what we're starting out with here, they cancel. That's what inverse operations do. So really, if you're comfortable, from now on, I'm going to skip that step and just write what's left. And what's left is your answer is just the inverse of whatever fraction you started with. Okay, so how you type that in on this calculator is the main screen has the regular sine, cosine, tangent, but over 2 tabs on the function has all your inverses. So we want the inverse tangent, but then we have to go back to our main screen to get our numbers, and we can just say 6 divided by 10, and then there's our number over here on the right-hand side. Okay, so we're always going to round to 1 decimal place, and that looks like 30.96 actually makes it go up to 31. So x is about 31 degrees. All right, I'm going to go ahead and box that, but it's nice to put it in our triangle as well. And we can go ahead and move on to the next one. Okay, this time x is on the outside of our triangle, which means we're not going to use the inverse. This just means we're going to have to solve for x the old-fashioned way. Okay, it saves us a step, really. Okay, from there we want to mark our angle, just like we did last time, and then mark all our sides opposite, adjacent, hypotenuse. Okay, so hopefully you're good with that, but go ahead and pause the video and get those labeled to kind of check yourself. 20 here is your opposite. The x that we marked is hypotenuse. And then the last one is adjacent. Okay, remember, if you're comfortable, don't even label that adjacent because it's blank. We don't have to label things that are blank because we won't use them. Okay, but here we've got O and H that we have to deal with. Again, we're going back to our SOHCAHTOA and looking for O and H in the same one. Okay, and that's with the SO. All right, so SOH tells us how to write our equation. The first thing says we're using sine. We always put the angle next, okay, just like we talked about right here. Always put the angle next. So then our angle in this picture was 40 degrees. And then we can set it equal to our fraction. This tells us our fraction, O over H. So our O in the picture was 20. Our H in the picture was X. To solve for x on problems like this, if you have it in the fraction with the regular, the step is always the same. You just have to multiply over the denominator. Okay, so when we multiply the denominator, which is x here, on both sides, these cancel. I'm going to go ahead and bring this down. This says x times sine 40 equals 20. Unfortunately, we haven't gotten x by itself yet, so we just have one more step. Since this says x times sine 40, we just have to divide by sine 40 on both sides to get rid of it. This is the same as cross multiplying, so if you're more comfortable with that, you can throw in the original step. I'll go back to it just to kind of show you. You can throw this over 1 and then cross multiply to solve if you're more comfortable with that. But it's still 2 steps. And finally, we're left with here x equals, since those cancel, and then 20 divided by that sine 40, which is what we get to go type in. Okay, so on this calculator here, sine right here. So I'm going to go ahead and clear out what we've got. 20 comes first, divided by that sign that I pointed out to you, and then inside gets to be 40. And our answer, right over here, 31.1. And in this triangle, since it is the hypotenuse, we can check ourselves really easily because that hypotenuse has to be the biggest number, and our other side was 20, so it is bigger. It works out for us. Next up, again, first step is decide if we need to use the inverse or the regular SOHCAHTOA. Okay, that'll tell us our last step to solve. This one, since we're on the inside, we're using the inverse. Okay, that's just a reminder when we get stuck on how to solve that. Everything else stays the same. Mark your angle. From there, we've got the opposite side we're working with and the hypotenuse. The adjacent is blank again, so we don't really need that one. But O and H, just like last time, is going to use so. What's different is this, we have one more step. We have to do the inverse after we set up this equation. Okay, but let's go ahead and look at what that equation looks like. S is for sine. After that is always the acute angle. Our acute angle is x here, that thing we marked. Then it's equal this fraction, O over H, which looks like 12 over 14. Okay, well, what's different about this equation is the x is on the left-hand side instead of on the right-hand side in that fraction. If it's not in the fraction, we're not going to multiply. Okay, we just have to use that inverse. So I said I was going to skip the inverse on both sides. You just have to say the inverse of that fraction. and that's what your x is. So let's go type it in. Remember over here, you have to go to your function for the inverses. There it is. And then back to your main screen, gets you 12 divided by 14. This rounds on up to 59 degrees. Notice on these inverse problems, you're always labeling it as degrees. That's because we're always solving with the inverse when we have angles. Alright, going over the next one here. We're looking at x on the outside, which tells us we don't have to use the inverse this time, just the regular SOHCAHTOA. Go ahead, pause the video for me, and mark your opposite adjacent hypotenuse. From there, I want you to go ahead and pick what your equation is supposed to be, and go ahead and try to solve it for me. Here we've got the opposite and the adjacent. The hypotenuse is not needed, so that is TOA, which means tangent of the angle, this time it's a 30 degrees, equals O over A. Our fractions order is told to us, so 5 over x. And remember, when x is in the fraction, your first step is always just multiply that denominator over. So here we're going to multiply by x on both sides. On the right-hand side, they cancel. We have x times tangent 30. That's not something we can type in our calculator yet because we can't type in x. We still have to get x by itself. Since this says times, we want to move it over by dividing by tangent 30 on both sides. Then, now x is by itself. We've got this 5 divided by tangent 30. That is okay to type in. So 5 comes first, then divided by tangent 30. Looks like about 8.7. And we're done with that one. Alright, number 5 here is a little twisted upside down, but otherwise it's the same process. Okay, x is on the outside, so we're using the regular SOHCAHTOA again. We're going to mark our angle, but we're going to be careful when we mark opposite adjacent hypotenuse because it's twisted upside down. Okay, as long as you remember that the hypotenuse is always across from the 90-degree angle, you should be fine. Okay, so 90 is up top. Across from that is the 5, so this guy is the hypotenuse. Then across from the angle we marked is always the opposite. And then the last one is the adjacent, okay, the one right next to the hypotenuse. With that, we are going to decide which sides we actually need here. The O is blank, so it's gone. And that leaves us A and H. So again, in your SOHCAHTOA, we're looking for which of those chunks has A and H. That's the KA, which tells us how to set up the equation. Okay, this is really the tough part, so I'm going to have you pause the video here and set up that equation for me. It should look like cosine of the angle, which is 36.9, then equals our fraction, A over H, looks like x over 5. Remember, when x is in your fraction, you just have to multiply the denominator. So this time our denominator is 5 that we have to multiply on both sides. But the nice thing about this is now x is by itself already. So we really only had this one step to solve, which means we're good to go ahead and type it in. So we just have to say 5 times that cosine of 36.9. And our answer looks really, really close to 4, so that's what we'll call it. All good. All right, number 6 is completely yours. Pause the video and take care of it. We'll check it when you're done. We're going to have to use the inverse on this one. Hopefully you recognize that since our x is inside the triangle, we're solving for an angle here. We've got the adjacent and the hypotenuse, so we're using the inverse cosine when we're done. Okay, so cosine of the angle x equals the fraction 20 over 29, since that's what a over h looks like for us. And then all we have to do is use the inverse cosine of that fraction 20 over 29 to take care of it. With that, we get an angle of 46.4 degrees. Make sure that you are labeling your angles with degrees. A lot of times I'll label my sides with units, but that's not as necessary. It's just a reminder of we got to label those angles when we put them in our answer. Last thing we're going to do is just a couple word problems applying to the SOHCAHTOA, either solving for a side or solving for an angle. First up is a pyramid. It says we're supposed to find the angle of inclination on this pyramid. Okay, it says that's the angle the lateral face, remember the lateral faces are the faces on the sides here, the triangles, but it's the angle that those faces make with the base, so on the bottom. Okay, well all of them are the same in a square pyramid, but basically we want to make sure we're labeling the one that is in the right triangle that we see. Okay, so the right triangle we see is right here. Okay, it's good to go ahead and darken that. And then the angle the lateral face makes with the base is actually this guy in the corner. So let's go ahead to the side and redraw that out just a little bit bigger, and we can label all the pieces on that triangle that we know. So first up is we're solving for that angle x. We want to put that in there. And then we want to label any sides that we have. So up and down you can see that that side length is 450, and that's good. But this 756 is the other number we have, and that's actually the length of the whole base all the way across. We only want the piece of the triangle. So half of that length is missing, which means we have to go take that 756 and just split it in half for 378 going across the bottom here. From there, it's a triangle problem just like the ones we practiced up above, which means we're going to use SOHCAHTOA to solve. Okay, our right angle is right here, making this the hypotenuse, this the opposite, and this the adjacent. So it's O and A that we care about, which means tangent. But remember, when we are solving for an angle, that means we have to use the inverse to get it done. So T is for tangent, our angle is x, and we set it equal to our fraction O over A. That looks like 450 over 378. Anytime x is on the inside here, we just use the inverse. So inverse tangent of this fraction, 450 over 378, and we can type that in. Inverse tangent, going back to my main screen here, 450 divided by 378, and we get an angle of about 50 degrees. That's it. Okay, so word problems aren't necessarily more challenging once you put x in your picture. Okay, so that's the hardest part, is we have to label our x ourselves, but everything else, once we get that done, is just like those problems that we've done before. All right, so last one here. It's got John is 6 foot tall, and he's looking up at a building of an angle of 20 degrees. If he's standing 100 feet away from the building, how tall is the building? Okay, so let's draw ourselves a picture since we weren't given one. Here's the ground. It's a good thing to start with. And we've got John, and we've got a building. Those are the two things we've got to draw. But let's label what we know. It says John is 6 feet tall, so that means this up and down distance is 6 feet. It says he's looking up at a building, so he's looking at the top of the building. So what we need to do is connect where John looks from his eyes, all the way to the top of the building, because it said look up. And it said the angle was 20 degrees. Okay, when we're talking about walking around, when we're looking out normally, it's when we're looking straight. And then we angle our head up to look up, we angle our head down to look down. Okay, so with that, our angle is based on where we're normally looking, which is straight across. And that's where the right triangle comes into play here. So anytime you're talking about looking up or down, it's from a horizontal or a segment going left and right. And we can put that 20 degrees in there. It also says that John is standing 100 feet away from the building, so that means this distance going across here is 100. I'm going to go ahead and put it on the right triangle here. And we're supposed to find this whole height all the way through here. How tall is the building? Well, on our right triangle, we can put x as this distance, and that helps us for most of it, but then we have to remember to go ahead and add in this distance as well. Okay, that little piece, if John walks up there, is also 6 feet. So our total height is whatever we get for x, and then plus 6. So we got to remember to do the plus 6 in the end, but we have enough labeled now that we can solve for x. We've got our angle here, so we can mark our sides: opposite, adjacent, hypotenuse. Remember, hypotenuse is blank, so we don't need it here. And then OA means TOA, or tangent. So tangent of my angle 20 equals O over A is x over 100. And then all we have to do, since x is in the fraction, is multiply by the denominator. X is by itself here, so we're good to just type in that 100 times tangent 20. Okay, so go ahead and type that in your calculator. And that looks like 36.4. But remember, that's x, and we still have to add 6. So I'm going to go ahead and over here say plus 6 to get 42.4. So the height of the total answer, 42.4. Everything was talking about feet, so I'll make sure that I put feet on my answer. And that's it, folks. Hopefully this helped clear up some of those things with 10.2 and 10.3, but let me know if you have any questions.